Hi there. This time we are going to perform the FEA on an assembly where you have more than one parts. And let's take an example of a simple laptop stand. So I've applied an appearance that looks like wood. I've also created a new material, which is the popular wood. And I have assigned that material as the physical material as well. If I click on properties for any of the bodies in my design, I can check that it is the popular wood. So once you're happy with the design, we'll go to the simulation workspace and create a static stress study. We are going to repeat the same steps. So make sure that you have assigned the correct material to the correct part. So let's go ahead and apply popular. If you have more than one part, you will have to apply to all of them one by one. Okay, and just to double check, you can actually click on properties and make sure that you're happy with these material properties. Click on OK, and we are going to apply a load case. So first, let's apply a force. If you click on structural loads, just select force and let's apply a force on this face. Let's make it 5 kilograms. So 5 times 9.81. Make sure you put the units and press enter. That is 5 kilograms apply on the surface. The next thing we are going to do is to apply a constraint on some of our parts. So this time we are going to click on structural constraints and fix the bottom two faces of our laptop stand. This time we are going to calculate the contacts, but you don't have to do it manually. You can just right click on contacts and click on automatic contacts. What this does is that if you have an assembly of more than one part, anything that is connected, it is going to create a contact set there, and Fusion will be able to calculate how stress is transferred from one body to the other. You might have to provide any tolerance. So if you've given a tolerance of 0.3, so make sure you put that tolerance value here. Next, you can go ahead and click on generate mesh. If your body is a little complicated, it might take a while to generate the mesh as well. Make sure you're happy with the mesh everywhere around, and then you can go ahead, check the pre-check and click solve. Again, once the study has finished solving, you can click on close and you can look at the minimum factor of safety. Right now is 15 for our current design. Also, the deformations are exaggerated, which you can see the actual deformations from here if you want. You can also animate and check how the deformation is going to happen in your part. And you can just do that by clicking on Resolve Tools and Animate. You can click play from here. You can see the deformation happening. You can do this for the stresses enabled as well and then click play. So you can see how the deformation would happen and the stress would be generated. But again, this is the exaggerated view. If you want to see the actual deformation, you can select actual from the deformation tab on the top and click play to see the animation of the stresses generated. You can also save these animations if you want to include them in your portfolio by clicking on the record button. Okay, the thing we have to do is to reduce the factor of safety. So what we are going to do is to remove material from our side edges of this design and also from this face. So let's go back into the design workspace and do some designs to remove some material. Once you have done the modifications, make sure you've not created any sharp edges because they usually lead to high stresses. If you have these sharp edges, make sure to apply a fillet value. So once you have filleted all of the sharp edges that you created, go back to simulation workspace. Again, Fusion is going to tell you that your design has been updated, so you need to solve it again. So just click on generate mesh to create the new mesh and then click on solve to solve it again. So once your simulation has been solved, you can click on close and observe the new minimum factor of safety. Although this factor of safety is lesser than what we had before, it is still well above the required factor of safety of 3 to 4, so you can still remove a lot of material from this design. So you would follow the same process. You can see where all the stresses are very low, and you can keep removing the material till the time you reach an acceptable value of factor of safety, that is 3 to 4. Hopefully this example helped you further understand how to do finite element analysis in Fusion 360.